What's up? What's up? What's up? What's up? Welcome back to another ASMR video. Today is going to be sort of a rambling video because I have gathered some facts about outer space. And if you have watched my first ASMR video, you know that I am very much into astronomy and cosmology, anything related to outer space. I've been into space since I was probably in middle school, so a very long time ago. And I have written down some facts right here on my iPad right next to me. And I did also a little bit of research for the facts I may not be 100% on. I did get some rough estimates of some numbers, some statistics, just a little bit, not a whole lot. But I hope you guys enjoy the video and possibly learn something new about outer space. Alright, so fact number one. The Milky Way galaxy, our galaxy, is set to collide with the Andromeda galaxy, our closest neighboring galaxy. So in about 4 to 5 billion years from now, the Milky Way and the Andromeda galaxy will collide to form a new galaxy called Milkomeda. And these galaxies are moving through space all the time. So right now, our galaxy and the Andromeda are drifting towards each other very fast. But even though it's fast, it's still going to take a few billion years for us to fully collide. So Andromeda is slowly drifting towards the Milky Way due to gravity, the gravity of both galaxies. And when they meet, most stars will not crash into each other because galaxies are mostly empty space. So due to the vast size of these galaxies, potentially, if our sun is still around in 5 billion years, if it does not explode, or if it does not turn into a red supergiant, our galaxy will most likely be, our solar system will be most likely unaffected by these two galaxies merging. But like I said, these two galaxies will slowly merge and shape into a larger galaxy, Milkomeda. And here's fact number two. Space is silent. So no sound travels through space. So on Earth, sound needs air or other materials to travel through. So space is almost entirely empty. So with no air, that means there's nothing to carry the sound waves through space. So that's why when there is an explosion, something merging in space, or like a supernova, there will not be any noise, and it will be silent to an observer. Alright, so here's fact number three. There are more stars than grains of sand on Earth. That is insane. So, there are more stars in the universe than grains of sand on Earth's beaches. Okay, the beaches, it doesn't include deserts, just beaches. So, astronomers estimate that there are hundreds of billions of galaxies, each with billions of stars. When you multiply those numbers together, the total is so large that it likely exceeds the number of grains of sand on all Earth's beaches combined. I think I read something that in the observable universe, that there's around, I think, 2 trillion. So I think there's about 2 trillion galaxies in the observable universe, but it's just an estimate from what we can see. And like it states here, each galaxy has around a few hundred billion stars. So yeah, it's pretty mind-boggling that still, like when you compare it to grains of sand on Earth's beaches, there are still more stars than grains of sand. It's very interesting. Okay, here's fact number 4. One day on Venus. One day is longer than 1 year on Earth. said that, I was like, wait a minute. What it should say is a day on Venus is longer than its year. One Venus day is longer than one Venus year. Let me explain that. So Venus rotates very slowly on its axis. It takes about 243 Earth days to complete one rotation. So to orbit one full rotation, 243 Earth days, one Venus day equals 243 Earth days. Alright. However, it only takes about 225 Earth days for this is not Venus, but for Venus to orbit the Sun. If this were Venus, if this were the Sun, it will take Venus 225 Earth days to complete one Venus year. So that means 1 year on Venus is shorter than 1 day on Venus because it spins very, 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 very slowly. Right. So the next fact is neutron stars are extremely dense. One spoonful of a neutron star material would weigh billions of tons on Earth. So neutron stars form when a massive star collapses under its gravity. Their atoms are crushed so tightly that protons and electrons merge into neutrons. This makes a neutron star incredibly dense, packing enormous mass into a very small space. And the only thing that's more dense than a neutron star would be a black hole, which I think we'll get into today. I forgot if I mentioned any black holes in my notes, but yeah, black holes are more dense than neutron stars. Infinitely dense. A black hole is infinitely dense. Alright, fun fact number 6. Sunlight takes time to reach Earth. So light from the sun takes about 8 minutes to reach Earth. So even though light travels extremely fast, the sun is about 150 million kilometers away. So the light we see right now actually left the sun about 8 minutes ago. Very, 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 we're very far from the sun. So, number 7. Some stars no longer exist. Some stars you see in the night sky are already gone. Stars are often so small, stars are often so far away that their light takes thousands or even millions of years to reach Earth. If a star exploded or faded away after the light began traveling, we would still see it shining long after it disappeared. Just because it just takes, like I said with the previous fact, it just takes light a long time to travel across space. Let's see what else I can find. So Saturn could float. Saturn would float if it is placed in a large enough body of water. So Saturn is very large, but made of mostly gas and has low average density. If there were a bathtub big enough, Saturn's density is low enough that it would float. I wonder if this applies to the other gas giants in our solar system, like Jupiter, Uranus, Neptune. The one I found was just for Saturn, but maybe for the other gas giants. It all depends on what gases make up that planet, though. Alright, here's a black hole fact. Black holes don't vacuum everything. Oh, low battery. Black holes don't suck in everything around them. A black hole's gravity works the same way as another object with the same mass. Objects only fall in if they get very close. From far away, a black hole pulls on objects just like a normal star would. So, a black hole has something called an event horizon, and if you get within that event horizon, you are going to fall into the black hole no matter what, due to the intense gravity. So once you cross the event horizon, you're as good as gone. Not even light, the speed of light, can escape the gravity of a black hole. Very scary. But luckily, we are not near any black holes at this moment. There is one in the center of the galaxy, but we're too far from it, so it can't get us. universe is expanding. The universe is still expanding in every direction. So after the Big Bang, space itself began to expand. Galaxies are moving away from each other as space stretches, and this expansion is still happening right now. And the expansion of the universe is, so technically, according to physics, it is faster than the speed of light. Very, very crazy because we are taught, light is the fastest thing in existence. However, if you look at it through physics, the expansion of the universe is faster than that. It's crazy, it's crazy, crazy. Alright, next fact is astronauts grow taller in space. And this is because without gravity compressing their spines, the space between vertebrae expand. This could make astronauts grow a few centimeters taller while in orbit. Very, very interesting. And I think it also depends, even if you're like on Mars, there's less gravity on Mars, so if you were to be on Mars, you would still grow a little taller, I'm pretty sure. Because Earth's gravity is greater than Mars. But I think right here, it's just saying, like, if you were floating in space. So yeah, can you imagine, like, astronauts on the International Space Station right now? Who knows, maybe they grew a little bit taller. Alright, let's see. Here is the size of the Milky Way. So the Milky Way galaxy is about 100,000 light years wide. So that means light would take 100,000 years to travel from one side of our galaxy to the other. Our solar system is located about 27,000 light years from the center. Yeah, very crazy. So even if we have achieved light speed in the future, it would still take forever just to go across the galaxy. It's insane how big galaxies are. And then when you think even outside the box, try to even think how big the universe is. You can't even comprehend it. Alright, our next fact is the distance to our nearest star. So the closest star to Earth besides the Sun is Proxima Centauri. That's a really nice name. It's about 4.24 light years away from Earth. So even at the speed of the fastest spacecraft humans have built, it would still take tens of thousands of years to reach it. And this just basically shows how spread out stars are in space and how incredibly small we are. Let's see. I think I mentioned this earlier, the number of stars in the universe, but this one kind of gives out a name. I'm sorry, a number. So it says there may be over 1 septillion stars in the observable universe. To give you an idea of the observable universe, the observable universe is about 2 trillion galaxies, like I mentioned in the beginning of the video. And the observable universe is only what we can see right now with our telescopes. That's just what we can see from Earth, the observable universe. So the universe can be way bigger than what we actually observe it as. So yeah, in the observable universe, 1 septillion stars. Right. So that is 1 followed by 24 zeros, which is insane. So let's see the age of the universe. The universe is about 13.8 billion years old, and this age is calculated by measuring how fast galaxies are moving away from each other and tracing that expansion